Welcome to my session. My name is Yong. I'm a principal data scientist from Outreach. I'm going to talk about continuous pre-training and the delivery of NLP models to optimize sales engagement. Here's my presentation outline with 4 major sections. Let's get started with the introduction and overview. You may or may not have heard of Outreach. Outreach is the #1 sales engagement platform powering more than 4,000 paid customers and growing. These customers include many well-known startups and multinational companies. So what is a sales engagement platform? Sales engagement platform encodes and automates sales activities such as emails, phone calls, and meetings, etc. into workflows, also known as sequences in our platform. For example, this diagram on the right shows a workflow where you can send an email and place a phone call on day 1, and then schedule a LinkedIn message on day 3, and then send another email and make another phone call on day 5. Due to such automation, sales reps' performance and efficiency can be dramatically improved up to 10 times better by doing more effective one-on-one personalized outreach. It turns out that sales process is quite complex and involves lots of different people with different roles. Starting with potential customers, which we call prospects, marketing team and sales reps need to start initial engagement. Once the prospects agree to meet, marketing account executives start to drive the deal to close, involving other people such as legal, security, and even finance personnel. Once the contract is signed, then implementation engineer and customer success manager need to help the delivery and success usage of the product. Account manager will also oversee the whole post-sale process and contract renewal and expansion. So how does machine learning generate a lot of data, such as emails, phone calls, and engagement logs, etc.? We then use learning from this data and combine with knowledge to provide a prediction, recommendation, and guidance for the continual success of reps. This becomes a flywheel shown on the left on the slide. The reason for changes due to various reasons. We already observed that COVID-19 changes how sales reps using content, and that's why it is important to enable continuous learning and guidance. To give you an idea, what are the typical business scenarios that could use NLP and machine learning? Here are 3 selected scenarios: sequence metric, objection handling, and sales personas and stages review. Notice that each scenario requires certain type of NLP models. Some of them are the select NLP and machine learning capabilities needed to support certain business scenarios. These capabilities range from entity extraction, such as job title and phone number extraction from emails, to refer to the same entity, such as persons, classification, such as classifying email or job title, seniority, and department system, which could auto-suggest templates based on email intent, or even auto-generate email text for content usage. Some of these capabilities are already in production in the Outreach platform. There are 2 distinctive challenges on a sales engagement platform for implementing NLP and machine learning models. The first one is that there are very limited labeled sales engagement domain text corpus. CCPA and GDPR, privacy and security concerns further constrain human annotation efforts. What's more, even if you could do human annotation, it is very costly to annotate so many emails from over 4,000 and growing paid customers. Second, as we already discussed, the sales process has changing context and players along the process, where the process progress in a non-standard way. There is no one-size-fits-all definition of the sales stages. Different organizations could have different segments, industry, and job roles involved, often causing out-of-domain problems for the model. So let's dive in to a specific use case called guided engagement. This is one of the outreach features. It is an inbox-based intelligent experience powered by an intent classification model under the hood. When sales reps receive replies from their prospects, existing or future customers, outreach predicts and displays the intent of the prospect's email. In this example, it shows objection already has a solution. Based on the predicted intent, relevant content are recommended to the sales rep to use. For simplicity, this talk will focus on the intent prediction using text classification model, not the content recommendation component. So why intent classification is such a core tech? This is because first, email is a core communication channel at a sales engagement platform. Email content is critical for driving results for prospecting and other stages of the sales process. Reply rate was commonly used as a metric for A/B testing different email templates or sequences. However, as we all know, the problem is that not all replies are equal. That means we must go beyond using reply rate. Instead of counting, we should do classification. That means we should automatically detect and classify the intent of an email reply and measure the performance of email template sequence based on the reply intent, and then use reply intent-based metric for A/B testing to find and optimize the email communication. Here are some example intents and corresponding email examples. For an intent of positive, willing to meet, the email might read with something like happy to have a conversation. For an intent of objection with no budget, the email could contain some sentence such as it may be priced out of your products, etc. And for an intent with referral, using specific contact's name in the email, you could find an email containing some sentence such as, please feel free to reach out to certain people directly. And finally, another common intent is basically unsubscription. You will find different ways to express the same meaning from the customer, saying that, please remove me from your list. So how do we develop intent classification model at Outreach? The approach we have taken is to use high-performance transfer learning, where pre-trained language model is used. This pre-trained language model have been shown very successful in NLP tasks leaderboard. When we see high-performance transfer learning, we mean it needs fewer labeled training examples, achieves better accuracy, and finishes with reasonable training time. An example on the right shows the red curve reaching higher accuracy with fewer training example is a higher performance transfer learning model than the green or blue curve model. One of the core science questions is whether we should do continual pre-training of the language model or not. A common practice is to use a public released pre-trained language model such as BERT, and then use labeled email examples to fine-tune an intent classifier layer so that we can get an intent classification model. However, due to the out-domain issues we discussed before in the challenge section, it might be worthwhile to use unlabeled emails to further pre-training the BERT model, producing a sales engagement domain language model, which we call sales BERT, and then do fine-tuning. So does this work better? It turns out that our initial results showed that the sales BERT plus fine-tuning approach has slightly better F1 score than the BERT plus fine-tuning model. So this is very encouraging. Notice that for this initial results, we only use about 6,000 unlabeled emails for further continual pre-training to produce sales BERT. So there are lots of room to improve this. Now let's talk about the engineer and production aspect of continuous delivery. Suppose now we have a trained NLP model for intent classification of emails. Does that mean we can now deploy to production as it is? Actually, not so soon, because when we actually deploy into production, there are various constraints and security concerns and even production requirements that are very different from offline experimentation and science experiments. So that's why we create 3 progressively evolved models for final deployment in a host environment. In our case, is the AWS Sagemaker. First, we create a fine-tuned trained transformer classifier, as we showed in the previous science slides. And then we wrap the same classifier with pre-process and post-process steps, which we call pre-score and post-score filters, which you can see in the diagram in the middle. And this entire wrapped pipeline becomes a scikit-learn pipeline. The reason we want to have some pre-score filters is because we want to add some logic, such as whether to parse the email and get the current reply message body only, or the full email thread. Or if the email size is too big, we will not apply the model in production at all. Or maybe we want to just reuse a cached prediction results if the email content is exactly the same. For post-score filters, we could add additional model metadata in the response so that we can track provenance from the caller side. Note that there is no model logic change in the classifier itself, but having this second model pipeline is much flexible. Lastly, in the production environment, we don't want the model to access our private GitHub, because accessing a private GitHub requires either a GitHub token or SSH keys, which are security concerns in an enterprise product environment. So we create a third model which packages all private Python dependencies into private wheels and then burn them into the Docker image, so that at the deployment time, the model can reference them without accessing the private GitHub. And that shows as the last stage in this preparation steps. Now we are ready to fully automate the deployment and continuous delivery through CI/CD pipeline. For continuous integration, we use Circle CI. The Circle CI pipeline not only does unit testing and style enforcement, but also runs the entire train, test, wrap, and deploy all the way to a Sagemaker endpoint at staging using a subset of the training data. This safeguards any code check-in. Note that several steps of Circle CI using MlFlow for execution. Now for CD part, that's continuous delivery and rollback. We use Concourse at outreach. This pipeline has two well-defined human gates. First, to trigger a full model building using full set of training data, a designated person needs to kick off the pipeline, and once it passes a regression test, a second human gate will also need a person to promote the model to a production endpoint. Here we deploy to AWS SageMaker US East and US West region. This makes the model as a service so that the client usage of the model can be through API call to the endpoint. In the CI/CD automation pipeline, we not only log the model, but also register the model using MlFlow model registry. From model registry, we can clearly see which version of the model is in production. If you click the version link, you then can find out more details and the provenance information of the model. So in summary, we talk about both science and engineering aspects of continuous development of NLP models. For continuous pre-training of language models, our preliminary result shows great promise to deliver high-performance transfer learning-based NLP models. Our future work includes increasing size of unlabeled emails for continual pre-training and experiment different enterprise segments, industry, etc., for different sales domain or subdomain pre-trained language models. For the continuous delivery of NLP model using CI/CD pipeline, the existing pipeline we implement provides a repeatable and efficient paradigm to continually optimize sales engagement with the latest models. Our future and ongoing work is to do A/B testing and implementing multiple models in production. Finally, I would like to acknowledge everybody in the data science group at Outreach who contribute and supports this area of investment. If you are interested in knowing more details about Outreach, please contact me at this email address showed on this slide. Thank you very much. I'd like to answer some questions.